Heliophysics is the study of the Sun and its interactions with the Earth and the solar system. Activity on the Sun emits radiation and high-energy particles into the space environment, affecting the conditions on the Sun, the solar wind, and the Earth system. Space weather refers to these conditions and their influence on our planet and the technology our society depends upon. Solar flares are storms that appear as explosive bright spots on the surface of the Sun and can emit radiation and blast electrically charged particles with an energy equivalent to 10 million volcanic eruptions. A coronal mass ejection, or CME, is the violent eruption of a huge cloud of plasma from the Sun's outer atmosphere, or corona. A CME can accelerate the solar wind, creating radiation in the form of energetic particles. An average CME can dump about 1,500 gigawatts of electricity into the Earth's atmosphere, which is about double the power generating capacity of the entire United States. Fortunately, the Earth's magnetic field, known as the magnetosphere, protects us from the most harmful effects of space weather. But some magnetic energy is transferred to our magnetosphere, which can induce geomagnetic storms. These storms can produce spectacular and colorful aurorae, but can also be hazardous to our societal infrastructure. Magnetic storms affect the strength of Earth's magnetic fields. On the Earth's surface, changes in these fields can induce corrosive electrical currents through gas and oil pipelines, as well as surges in transformers and power lines. A series of solar flares and a CME in March 1989 produced intense magnetic storms that left millions of people throughout substantial regions of Quebec, Canada, without power. The Earth's ionosphere acts like a natural relay station, bouncing radio waves assisting communication around the globe. Geomagnetic storms can disturb this layer of our atmosphere and can completely wipe out high-frequency radio communication around the Earth's poles for days. These disturbances with radio communication can be particularly hazardous to the growing number of aircraft flying over the poles. Geomagnetic storms can disrupt navigation, communication, and electrical systems on the aircraft and even expose the aircrew to high levels of radiation. The disturbed state of the ionosphere can also impact our society and economy by disrupting communication with satellites. Disruptions can occur in our day-to-day business activities, such as ATM and gas pump transactions. Disruptions with GPS communication satellites can not only impact our car navigation systems, but also navigation systems on tractors used for precision farming and those on commercial fishing vessels, which can impact our food supply. Above our atmosphere, satellites orbiting through the Earth's radiation belts and the solar wind are affected when energetic ions accelerated by solar storms can disrupt their onboard computers and degrade their instrumentation and solar panels. Astronauts that live and work in space on the International Space Station can be exposed to high doses of radiation during solar storms, even when they are inside. Successful forecasting of space weather is vital to mitigating effects on our infrastructure. NASA expands the frontier of space environmental prediction by conducting remote sensing and in-situ spaceflight missions for collecting new scientific data, developing advanced models to interpret these data, and creating national archives for scientific products and results.